All right, let's talk about my favorite thing, high-strength wastewater. High-strength wastewater is generated mostly in food and beverage applications. These can be a result of clean-in-place processes when you're manufacturing syrups or refining sugars, jams, jellies, really high sugar applications. You're going to generate a high-strength wastewater no matter what. So what do you do with it? And largely that's going to depend on where you're operating and what the city is going to allow you to discharge. And so how we're going to define high strength right now is with a number, right? Which is a concentration associated with biological oxygen demand and or chemical oxygen demand. So high strength is going to be anything that would fit into an anaerobic digestion process or more, right? So it wouldn't be possible or it wouldn't be cost effective to use any sort of aerobic activated sludge or membrane bioreactor process. Usually that number in BOD, COD concentration is above 10,000 parts per million and higher. So when you're operating and discharging in concentrations like this, you have to take into consideration, okay, where am I operating? Can the city let it go down the drain? If that answer is no, you're going to have to haul it somewhere. So you have to pay a hauling company so it can dispose of it, either taking it to a different municipality that can treat it, or may land apply it somewhere. Your other option is to do industrial pretreatment on site. Now, in order to be cost effective in doing this industrial pretreatment, right, you want to make sure that you can separate your stream efficiently, because probably most of the time in your manufacturing process, most of your water is not going to be 10,000 or more. Most of your water is going to be on the lower spectrum. But some of your processes are going to discharge, somewhere up of 100,000 parts per million, and then that's going to mix in with the rest of your flow and start causing problems. So what about isolating those specific processes? Sometimes you might already be side streaming. So if you're side streaming a bad batch of syrups, if you're side streaming a crushing operation, that means that you're capturing that particular discharge and then you're dealing with that differently than what's going into your floor drain. That's a great strategy, because if you have to do on-site treatment for those high concentrates, right, around 100,000 parts per million, that means you can have smaller equipment on site and you can get it down to a quality that's going to blend in with the rest of your flow, which you can either retreat and reuse on site or go to sewer without major cost. So let's talk about stream separation and your options for that. One is already captured, right? That's done mechanically in the plant. So you have a diversion. You know these processes that are generating these really high strength streams, and you catch them in the act, and you put them into a separate tank for storage, treatment, hauling, etc. The other way is to concentrate. So everything goes to your floor drain, to your sump. You run it through a concentration process, which is typically going to be a membrane filtration process. And then the clean water can be brought back in for reuse, potentially after some disinfection, or sent to sewer at very low cost. And then the brine can go to an alternative treatment strategy like AquaCycle.